了多少天，心中对你的思念，经过了多少年，爱情美好的画面，读过了多少遍，这份不变的情缘，不管期待多少年，无悔无怨。无论在海角在天边，啊，在我的心里面，我对你深深的情永远不变。就算今生不能在一起，我也不会忘记，期待着和你再相遇。我忘不了你，也放不下你，期待着和你再相遇。
Begin animation in RPGSTART programming. Last time we prepare for drawing. Today we try to teach something about animation. We have put Jing Adams RPG version 2 on our websites. If someone interested about animation can download the file and expand. It is book course RPG2 from chapter 1 to chapter 16 of RPG2 of Jing Adams, and even game codes are available. Today we try to use the example of chapter 8 and to see the contents, how it works as running, and how to compiling each of the chapters. Some chapters are compilable, so can be run. Some maybe not work. If something you can debug and run, then we can copy and insert into RPGSTART program. It's an easy way to edit a program. Right, let's start. We still C++ 60.0. And open the chapter 8. To go to C and book codes RPG2 and chapter 8. There are 4 file folders. In chapter 8 we open our objects and open objects.dsw. This is the program inside the chapter 8. We can survey in here the vman cpp without vman.h. Vman.h and the vman cpp can combine together. Let's see. Right now it's in vman cpp. The vman cpp original in our program is vman and the frame and the shutdown and the initial and the capp. And this area belong to vman.h, capp, C application, private and public. So it combined together. previous in the program we have core graphics cpp, core graphic.h, core system cpp, core system.h, and vman and vman.h. Right now, today in this program, the mouse are used, and the 3D clippings are needed. So the code input for mouse.cpp is here. The code input.h together, and for 3D clipping, the fraction.cpp and the fraction.h are available. You can see the code input is from Genko. In here is from the book code, but in our system we should come from Genko. The book code is Genko code cpp. Okay, so we prepared the last RPGSTART, increasing input and increasing fraction, just equivalent to chapter 8 program, because we cannot use a text file in Windows 64 version. Okay, let's see what we run chapter 8 to get. The first things we have to compiling chapter 8. How to compiling? Just build all, execute it. If the result is 0 error, 0 warning, then we can use start debug go to see what we have. Right now you can see 3 of 256 objects shown. The number at the left top is the monster, the number of the monster inside the window. As the mouse moves, the camera moving, so we can draw in dynamic. Okay, we try to copy everything from chapter 8 to work in RPGSTART as the beginning to write animations program. Let's survey. In this area should be long to vman.h. The graphic app initial shutdown already exists. The things we have to copy is from here to here. A class of camera and objects and cameras created. Phone to write the characters, how many monsters to show on the screens. We need a taxi phone, so we use C phone class to create a M phone. Input is the device. The direct input can work for mouse, for keyboard, for joystick. An input device is a mouse. We have only one mesh, the mesh for the monster, but we open an array 256 objects. Each object is created from the mesh, from a single mesh. So this is what we need to copy. Okay, we highlight the area and press the right key and press copy and leave the object program and into rpg1.dsw back to our original RPGSTART program. First of all, we have to see in here the code graphics. Okay, code input are added. Code input.cpp, code input.h, and the Flatron.cpp and the Flatron.h are inside in here, while code input is from Genco. It belongs to DirectX code input and code input.h as well. Genco code input.h, but the Flatron are not DirectX functions. So it is independent program. So we copied Flatron.cpp inside RPG demo RPG1, and the Flatron.h the same being copied inside RPG demo RPG1 and attached already in source file and header file as well. Right now we just copy the contents, then we can put into Vmax H at a private area. We put a cursor somewhere beneath graphics, a cursor flashing in here, and use edit and press pass to add the copied definition of camera phone input mesh objects on this area, and then press Save All, then leave RPG1 and then go back to the objects to copy the rest. After the main finished, we start to copy the initial parts. The initial parts, the original definition, a little difference from here, but similar. We finished initial graphic set mode and the graphic set perspective. Then from here to here, show mouse. After show mouse definitions, then we can use the mouse functions later on in the frame, and we open the device of direct input and open the mouse, create a mouse. A mouse could be used at later on, and use mesh load to load the single mesh we have from the folder data parallel to RPG1s, and inside the data folder there is a X file named uden.x. It is a monster, so we have to create a data in the same level as RPG1 and copy uden.x from chapter 8 data area, and you can see double dot in front of data. That means the data are the same height as RPG1, as the folder we are writing the program. And we can, in the Vmax, we open the 256 objects. The maximum objects can open is 256. At the initial, we let the open 256 objects created from the single mesh at the same positions, and then use a object move to move this 256 monster into a random place. The SY in dynamic join, the Y and the Z are upside down. You give the random variables inside 4000 minus 2000. That means the positive 2000, the minus position 2000, and the Y as well. So the monster located at the center, and then use the object move to get around the original point in the radius of 2000 millimeters. This is what the initial does. So we copy it to our RPGSTART program by pressing the right button of the mouse and choose copy and leave objects and re-enter RPG1 and find the place of initial, which is located in Winman. Initial beneath set perspective, and find a place, press the cursor and press edit and press choose past. So the mouse, the phone create the input initial, the direct input device opened, and the mouse create and the mesh loaded of Uden, the monster, as file in geometry, in 3D geometry acceleration card, and create 256 monsters by using only one single mesh, and separate these monsters in a circle 2000 around the center. Okay, finished. Then save it and leave RPGSTART RPG1 and re-enter the objects to copy the rest datas programs. Initial, then we shut down first. In the initial, the object mesh are used. So in shutdown, we have to free the objects and free the mesh. The phone are used. In shutdown, we have to free the phone, free the mouse, and shut down the input, the right input device. This is what we have to copy from shutdown. And just copy and close objects and re-enter RPG1 and find the right place inside the Winman and find the shutdown place and press the cursor and press edit, press past. So at RPG shutdown, we free objects 256 and free single mesh and free the phone and free the mouse and shut down the input device. That's it. Then we save it and leave RPG1 and re-enter objects. So right now we copy from frame. The frame open the 4. One is number of John, another radius and the states, and open a C-front objects. Then read the mouse and allow mouse walking, and the camera move to 100 0. That means our cameras to get a viewport located at 0 original positions, but 100 millimeter in Z direction in height, and let the camera rotate relatively by mouse. The mouse moving, then we can use mouse get a Y delta divide by 200, that speed slower, and in Y yes get extra delta divided by 200. So by camera rotated relative and by mouse read, as we move the cursor, the camera will move dynamically around the surface of the window. Then set the camera, and then use fraction construct according to camera. We can create a pyramid, and fraction construct will project the drawing inside the pyramids on the screen. And this has to be copied first. Press copy and leave the objects and re-enter RPG1. And find the right place frame and paste. So in the frame, number John, radius, states, and a fraction object defined. And at the beginning of the frame, mouse read, so we can use mouse later on. The mouse are using in here to locate, to rotate relatively the camera. The camera's original locate at 100 in Z heights. As the camera position defined, then set the camera. The camera will create a pyramid. Inside the pyramid, we can use fraction construct to generate a pyramid. The monster showing inside the pyramid could be displayed on the project square windows. This is the way fractions does. Okay, right now in here is okay. Then we can see, we'll see next what walking between begin scene and end scenes. So we save first, save all, and leave RPG1 and re-enter objects program. So between the begin scene and end scene are these program from 0 to 256 to handle the objects. The object started from 0 until 255. Use fractions get bounds. For object 1 to get bounds, to get the radius. The radius is the maximum size of the monster, and use fraction check sphere. An object can get S position, get a Y position, and get Z positions. The located of the objects, since we know the 256 objects are located arbitrarily, so we can use get S position, get Y position, and get Z position for that specified objects, and the radius for every object are all the same. With these parameters, then we can check spheres inside the display, inside the camera pyramid or not. If answer is true, then we render the object. Otherwise, we don't render that objects. If we render the showing objects, then we have to add number zone. The number zone started from 0. If single objects, if these objects are inside the camera's pyramid, then number zone plus plus add 1. So number zone become 1. And so on. If at the last number zone 60, that means 60 monsters are joined on the screen, then display statistics. We write number zone by these formats. Suppose we say 60. The 60 will replace 100% 1U. That means 60 of 256 objects join will feed in the states, the string, and use phone print. Print what? Print 60 of 256 objects join. On where? On 0, 0 position. The x0, y0 positions is at left top corners, started from left top corners to show these characters and unseen and the display. Okay, let's copy these lights and leave objects and re-enter the RPG1 and insert those lights copied in the right positions, just between begin scene and end scene. Although in chapter 8 we thought enable buffers, but we leave enable buffers layers, no problem. And in here we just edit and paste the copied file, the copied program inside the right place. Okay, this is what we have copied to handle the object from 0 to 255. The object will get bound first to get the radius to cover the monster, and use fractions check spheres. Input the location of the monster XYZ and the half radius of the monster. If the answer is true, this monster is inside the pyramid of camera scene area, then we have to let that objects be rendered and number zone add 1 and so on. If the accumulation of number zone is 60 at last, we have to put number zone here. The value of number zone is 60. The 60 will replace 100% 1u. So the string written will be 60 of 256 objects of zone will be put inside states and use form print to print the states at a 0, 0 position, the x0, y0. So the x0, y0 is at these points, left top corner. Type what? Type 60, type the contents of states. What is the contents of the states? The contents of states is 60 of 256 objects zone. That's it. Okay, let's save all and rebuild all. If the results is no error, then we can run to see what we get. Oh, there are 5 errors. Let's see what happens. Press the cursor in this area and press Ctrl and F together. And in here, find what in this area? Right arrow. So the program will show here first chunk undeclared identifier. The first chunk is an array. Okay, let's see the first chunk. The first chunk we input the CPP in here and the first chunk.h in here. But in the program we have to include the first chunk.h. Let's see if there is any include or not. To go to the top positions, we include global.h, include women.h without include first chunk. So we copy the include and the type first chunk. First tone .h in here. Okay, let's compile it again to see if no error or not. After we adding fraction.h at the main program, there is no errors. Okay, if no errors, let's run. Before running, we have to make sure something is about the data area with the udon x. Let's check. From C, RPG demo, there is no data file. So we have to open a new file folder and changing the name to data, and then to copy udon inside the data area. From where? From chapter 8, from the book code RPG2 chapter 8. The data areas to find the udon. This one is S file. This is what we need. But without this udons JPG file, we cannot have colored udon. So these two files has to be copied. So we highlight these two files and copy, duplicate, and then go back to RPG demo and to open data and find a space place and press the right button of the mouse and stamp them into the data file. Right now the data are available. Then we go back to RPG1, and since there is no error, so we started to run. Set debug, go. We'll see 256 monsters on the screen around a circle 2000 meters radius, and we can move the mouse to move the cameras to see the monster. The number of the monster are showing at the left top corner. Right now 18 of 256 object shown. Then we change the background color to the original objects, maybe better. Then we close the program and go into the positions to show the background. The backgrounds RGB is 0 in R, 64 in B, in G, and 255 in B. So we change the program back and save all and build all. If no error, then we run again and finish these demonstrations and go. Okay, and the characters since quite clearly 76 of 256 objects shown dynamically join the monster.
埋藏了多少天？